Windows, Linux, macOS, Android, iOS, you frequently hear those names, you use them every day. But what are they? Well, those are specialized softwares called operating systems. An operating system is mainly used to manage links between all the applications worlds, so between the softwares and the physical world like processors and so on. Remember that a computer is made of three main elements. First, the memory, which I will represent here with a small cylinder. The memory is used for storing data and access it when needed. Another important element in computers are the processors. Processors are the computer's brain. They perform calculations and execute tasks based on the data they retrieve in the memory. Finally, for the computer to communicate with the outside world, it has output-input components, such as, for example, a printer that allows data output, a screen that allows data display, a keyboard which allows data input inside the computer, or even a mouse. Internet is also an input-output component. Computers run several applications. You can have 3 different applications running on a computer. Each application will execute a specific task that depends on the use you have for it. In fact, for applications to be able to use the hardware, you will not grant them direct access to the computer's components. No, you get an operating system between the two. So you will have the operating system, typically OS in English, which means operating system. So that's what will be the link between the apps and the computer. So we can see there are 3 main elements on a computer: memory, processors, and output-input. So the operating system makes the link, like this. We could picture memory as a great chart with several entries. We call them words. Every word in those charts corresponds to an address. Address 0, 1, 3, and in this case we can insert 4 words into the memory. Those addresses correspond to where exactly they belong in the physical memory. What an application can do, for example this one, wants to insert a word into the memory, it wants to insert Toto, it wants to insert it into word 1, so it will insert Toto here, in the word 1. So it will be written in the computer's physical memory. Once the app has written, it should be able to access it. But let's imagine that a second application inserts the word Zut here, but also in the memory word 1, so it will write here and it will substitute Toto for Zut. There's a problem here, because if that application decides to go back to the memory to retrieve the last data it had stored into the word 1, it will obtain Zut instead of Toto. That's not right. The operating system will be able to prevent such problems thanks to virtual storage. The idea behind virtual storage is that the operating system will give each application the illusion that each has the whole memory available. But thinking it has the whole memory available, again, it will want to insert those 4 words with a 0, 1, 2, 3 address. Each app will do the same. Now when an application wants to write something in the memory, it won't write directly into the memory, so it won't do this. It will write in the virtual storage instead. For example, it had chosen to write Toto on the word 1. What the operating system will do when it receives a write-in-memory command from an application, it will convert this. It's going to find a space to write the data in the real memory. For example, it can say, I will write the 1 here on word 3 in the memory, so Toto. So it will be written into the physical memory here, and the operating system remembers that the 1 for this application belongs in fact to the memory word 3. Now if that application here, which was also writing on the word 1, still decides to write Zut on word 1, then the operating system will find a space in the physical memory where the word Zut can be inserted. For example, it decides to write it on the word 1. So Zut will indeed be inserted here. And the system will remember that word 1 for this app corresponds to word 1 in the real memory. So from now on, if the first app chooses to read the word it had chosen as word 1, the operating system will remember the data was stored on word 3. With word 3, we retrieve Toto. There are no more inconsistency problems between the several apps that could overwrite one another. That's the aim of virtual storage. So we can see that virtual storage has several uses. But our drawing also shows that we only have one processor. A computer generally has a few processors, or at any rate a lot less processors than applications. So the operating system will act as a moderator between the different applications in order to share the processor, because a processor is actually a little dumb. It just performs calculations and does only one task at a time. So if two applications want to use a processor, they have to wait their turn. Just like at school, when a pupil wants to ask a question, he puts his hand up and waits for his turn. But the operating system will do the same thing through scheduling. Scheduling will say, that application has done enough calculations on the processor for now, so I'm going to put it on break to allow other applications to use the processor. What can also happen is that maybe this application does a calculation, and then at a certain point it has to read the hard drive. The hard drive is much slower than the processor, so the app will have to wait for the data. So it's going to retrieve the data on the hard drive, and during that time, it stays on pause, which frees the processor for another application. Once that is done and the data has been retrieved, it will be able to go back to the processor. So with that, we have the first two elements. The last element is considering that computers are always different. There are lots of different modes. A cell phone is a computer. A chip card is a computer. Your personal laptop is a computer. A big Google server is still a computer. What we want is for applications to be able to write without having knowledge of how hardware is actually made up. That's why the operating system provides an abstraction layer through system calls. What are system calls? Every time an application needs to execute something on the computer, it won't execute directly on the memory or the hard drive. No, instead it will ask the operating system to do it in its stead. So for example, if an open app wants to write a rectangle on a screen for a game, what happens is, the app asks the operating system draw me the rectangle on the screen. The first thing the operating system will do is check whether or not the application has the authorization to draw on the screen. If it does, then the OS verifies how to perform the drawing, and will execute the drawing in the application's stead. The same thing happens if you want to read from a microphone. There is a microphone app, for example this one. It will say, I want to record the sound here, which is being retrieved by the microphone. To do that, the application will tell the operating system, I'd like to listen to the sound with the microphone. So the operating system will be listening via the microphone, and as soon as a sound event occurs, the microphone will relay a signal to the computer, which will generate an interruption for the operating system. And it will realize I have a signal coming from the microphone. And indeed that application asked me to relay microphone signals. So the OS will relay the right signal to the right application. So we saw that the operating system has three main purposes. Manage memory with the virtual memory. So it will enable an even distribution between applications, a safe memory management, so that an application cannot use memory belonging to another application. The second purpose of the operating system will be through scheduling. It will allow to share the load of the various applications on the processors, and it will abstract the computer's technical details from the applications, so that we can write with an application without necessarily knowing which computer is going to be running. The question you could ask me now is, yes, but there is Linux, Windows, MacOS, Android. Those are all different names, different systems, and you are telling me that the basic concept is the same? Actually yes, conceptually, it is the same thing. What changes is the ecosystem delivered with each system. iOS is more network and developers oriented. It is more dedicated to final users, games, but also usage license. Some systems are locked, so they cannot be modified. Other systems are open, so they can be modified at will. So depending on what needs you have, you will choose one system over another, more or less dedicated to what you intend to do.